I decided to make this tutorial in the evening time of X-Plane since part of it will be covering the cockpit lighting controls. This is the audio source selection subpanel. The knob in the center is used to select which audio source you hear in the cockpit. The RK1 and RK2 modes will allow you to hear the Morse code of any VOR that you may have dialed into. So for example, we are currently parked at Peshawar Airport in Peshawar, Pakistan, identifier Oscar Papa Papa Sierra. This airport has a VOR that is located on field with the frequency of 114.3. Let me go ahead and dial that in using the navigation 2D panels. It looks like I already have 114.3 dialed in over here. So if I switch the audio subpanel to the RK1 or RK2 mode, you can hear the VOR Morse codes. The Morse codes can also be heard on the mode RK2. Just as a side note, we pronounce them RK1 and RK2 modes even though it looks like PK1 and PK2 because the alphabet character that looks like an English P in the Russian language makes the same sound as the letter R in the English language. Although this switch isn't described as being implemented in the aircraft's manual, through experimentation I have found that it acts as an on-off power switch for the audio panel because when it is in the down position, you cannot hear the Morse codes anymore. The other audio modes are not described in the written manual and are probably not implemented. Furthermore, this is another instrument in the aircraft that seems to have only been designed in Russian textures, just like the magnetic compass which I showed you in my last video. This knob is a rheostat that controls the amount of ambient red night lighting in the cockpit. I can increase or decrease the red ambient night lighting. These two knobs are also rheostats, just like the first knob, and they control the amount of flood lighting in the cockpit. The left one is for the captain's area, whereas the right one is for the first officer's area. You can use these to increase or decrease the white lighting or the flood lighting in the cockpit. This is the roll control unit test switch. When you open the cover and toggle this switch, you will see its green light activate or come on. You will also notice that the artificial horizon or the AI warning lights will light, and the red light next to the AI will also indicate failure mode. Furthermore, the reserve or backup AI failure flag will also appear. This is the GPWS or the Ground Proximity Warning System test switch. The written manual for the aircraft states that when you test the system, the pull-up lights are supposed to illuminate and the buzzer is supposed to sound. However, I tried this switch in all the available 3 positions, but I cannot seem to see anything happening. I do know that the GPWS alerts the pilots to diminishing terrain proximity via this light, which reads danger terrain when it goes off, as shown in the inset photo right now. I would think that the GPWS system test switch would make this light go off, but it doesn't. Perhaps this feature didn't get fully implemented? If you find otherwise, please indicate by commenting on this video so that we can learn from you. This is the engine start system ampere meter, and it shows the current draw of the engine starting system. Similarly, this is the engine start system voltmeter and shows the voltage available in the engine starting system. This meter should be checked while starting the engines to ensure that the voltage doesn't fall below 19 volts, as indicated by the marker. Though the author does not indicate what to do if it does, I would imagine you will want to abort the engine start and investigate the cause. Before we go on, We will briefly take a look at the An-24's hydraulic system to enhance our understanding of it and the associated instruments. This is a very simplified and undetailed diagram of the X-plane An-24's hydraulic system that I was able to put together based solely on what I read in the aircraft's written manual, as I do not have access to the real aircraft's documentation. It does not represent the hydraulic system of the real-life An-24, nor does it accurately represent the X-plane An-24's hydraulic system, because I simply don't have enough information about it, since the written manual provided by the author doesn't fully describe it. I only made this diagram to help understand the X-plane model a little better. For the purposes of this diagram, when I say An-24, I'm referring to the X-plane aircraft and not the real-life one. The An-24 has two hydraulic buses, a main bus and an emergency bus. Normally the main bus will operate the hydraulic devices via the motors and valves of those devices, which are labeled M and V for each device respectively. As you can see on the top, some of these devices are the flaps, the landing gear, the nose wheel, steering, wipers, left brake, and right brake. The manual states specific devices controlled by the main bus, but then it also says that the main bus controls all the hydraulic devices. So I tried to make the diagram generic in the sense that I included the brakes, but I didn't include things like the ailerons and elevators, so as to stay consistent with the written manual. In the main hydraulic system, the two engine-driven pumps feed an accumulator to maintain a pressure of approximately 106 to 120 kilograms per centimeter squared. The accumulator then provides the hydraulic fluid pressure to drive the hydraulic motors of the hydraulic devices, and then the fluid returns to the reservoir to be pumped again as needed. If the main bus goes offline for whatever reason, the emergency hydraulic bus can be used. The emergency bus is shown in red color in the diagram and provides a pressure of 120 kilograms per centimeter squared. This bus can be cross-tied to the main bus via the cross-tie valve shown here. A big difference in the emergency bus from the main bus is that this bus is fed from an electric pump instead of an engine-driven pump. This makes perfect sense because that is the configuration that would ensure that you still have control of the aircraft's control surfaces in case both engines fail. Another difference from the main bus is that the emergency bus can only extend the flaps and the landing gear. It cannot retract them. Furthermore, the flaps will extend 4 times slower than they do with the main hydraulic bus. In cases of an emergency, the landing gear can also be lowered simply by its own weight. Let's get back in the cockpit and take a look at some of the instruments having to do with the An-24's hydraulic system. This gauge shows the pressure in the emergency hydraulic system. These two gauges show pressures in the main hydraulic system and the main hydraulic system accumulator respectively. These two gauges show the pressure in the left and the right hydraulic brake lines. You can see as I activate my toe brakes, which I'm doing with the rudder pedals right now, the pressures in the brakes fluctuates to show the relationship between the pressure changes. Very nicely modeled by the author. Here's something else that is very interesting that I will show you. I'm going to go ahead and just turn around to shut off both engines. As both engines are winding down, I still have pressure in my hydraulic system from the engine hydraulic pumps that I showed you on the diagram earlier, but watch what happens as I lower my flaps. You see the pressure in the hydraulic system is now starting to drop, so I'm going to continue lowering the flaps. Pressure has dropped as much as it's going to drop, and flaps are almost at maximum extension. I'm going to let them get there. Okay, so now my flaps are fully extended and I'm going to try to retract them. And as I'm pressing the button, you'll notice that nothing happens. Well, that's because the hydraulic pressure has bled out and hasn't been replenished by the engine pumps because I killed the engines. Now, if I cross tie the emergency bus into the main bus by using this cross tie switch here, when you click it, it goes into this position. As I try to raise the flaps now, you will see that they are coming up. And you can see that the pressure bleeds because the emergency bus is a much slower bus. It can't build the pressure up so fast. If you slowly wait and watch these gauges, the pressure will eventually rise, but it takes time. That's why, remember when I said it will operate the flaps, but up to 4 times slower than the main bus. And you can see how the pressure drops. That's why it's said that the emergency bus can only extend the landing gear and the flaps, but cannot retract them. You may not get a full retraction cycle before it runs out of pressure. I'm going to skip these two instruments for now and come back to them later, because since we're talking about the hydraulic system, I'll continue on those instruments. This gauge shows the quantity of the hydraulic oil in the system. That is all that is written in the manual about this gauge, but my hypothesis would be that it represents the amount of hydraulic oil in the main bus reservoir that I showed you in the diagram. These two gauges are indicators of oil quantity. That's all that's written in the manual, but I would guess it means oil quantity in the engines since there are 2 of them and they're identical to each other. This is the APU fire valve. The red light indicates that it is closed. You can flip the switch up and after a small delay, the red light will go out and the green light will go on, indicating that the APU or the RU19 fire valve is now open. This is the ACHS-1 chronometer. It is a popular aviation clock used in older Russian aircraft. The bigger main dial shows the time of day in Zulu time, not the local time. So if I show you here, even though my local time right now is 12:36, Zulu time is 07:36, and therefore that is what the big dial around the clock is showing. The smaller upper dial is useful for counting minutes. Basically, it is a minutes stopwatch. It will count 60 minutes around the dial when you press this red button once. The small red flag in the clock indicates that it is counting time. Press this button again and the flag changes to half red, half white. That means the clock has stopped counting time. Press this button again and the flag changes to all white, which means the clock has been reset. I'll go ahead and start it while I'm demonstrating the other features, so you can kind of get the feel for the speed of this clock. The smaller lower dial works similarly, but it counts seconds. So basically, it's a seconds stopwatch. It will count 1 minute around the dial when you press this white button on the right. You can see it has started counting. The start, stop, and reset functionality of this button is identical to the other red button. The only difference is that this clock has no color flag indicator in it because the needle moves fast enough to be able to tell what the status of the clock is at a glance. Please note that this clock is synchronized with an identical clock on the right-hand side instrument panel, which is in the first officer's area, and that will be covered in a future tutorial. We now move to the horizontal part of the left side panel. Here we have the rudder position indicator, or the UPRT. Note that as I move the rudder pedals, it moves in sync to indicate rudder position. Click on this tab and you will expose the engine starting instruments, which are the engine start button, the engine start system annunciator, which indicates that an engine is starting, the engine start mode selector, which selects from two modes, ground start or air start, the engine selector, which is used to select which of the two engines you want to start, another mode selector where fake means cold spin or just a spinning of the turbine without actually starting the engine, as opposed to start, which means a real start of the engine. The engine start abort button in case start readings aren't normal or something goes wrong. The left engine exhaust gas temperature or EGT control switch. This switch seems to imply that there are three ways to interpret how you want to monitor the EGT, since I noticed that toggling this switch does slightly change the EGT reading on the gauges in the middle panel, which we have not yet covered, but no mention is made of what the different modes mean. The left engine control system switch, which I imagine turns on engine controller hardware, but its specific purpose isn't mentioned in the written manual. These two switches are the same as the last two in functionality, but for the right engine. Next, we have similar controls but for the APU, or the auxiliary power unit, also referred to as the RU19. We have the APU start button under this white cap, the APU start mode selector, the APU start system main switch, the APU start abort button. Slightly forward of the engine and APU subpanel are four more controls, which are the ground proximity warning system switch. The lower position means the system is on, as indicated by the green light. The main and emergency hydraulic system cross-tie valve. This is the open position, as I covered earlier when I was demonstrating the hydraulic bus, and this is the default or the closed position. This is the windshield wiper switch, which turns on the windshield wipers. And finally, the autopilot servo's emergency disconnect. That covers the instruments on the left side panel.